Alright, so part 3. Here we go. What I want you to do on this, to start the video, we're going to do this for bonus points, okay? I want you to solve this algebraically. I want you to solve it with graphs. List out the intersections if there are intersections. What's going to be different about this that you already noticed? It's going to be inequality. It's going to be shaded regions and stuff. So be very accurate with your graph. I want you to write it on the piece of paper. We'll go over the answers and bonus points at the end. You'll have, let's say, 6 minutes. Alright, resuming the video, guys. Right now, the purpose of you working in your groups when you do the way you are is I want you to show the experiences that you guys are each seeing with these problems, because you will learn the good and the bad from other people. If I just showed you these day in and day out, just me working them, you don't learn as much. I promise you, you don't. But if you go and you're sharing ideas with your group and you are taking ideas, you learn a whole lot more. Here we go. Algebraically, let's solve this algebraically. We have 3 absolute value of x. We're going to subtract 2 to get this. My goal algebraically is to isolate the absolute value sign. Okay? Divide by 3. 0 divided by 3 is still 0. What is 3 divided by 0? Undefined. You cannot divide by 0. And there's a cool video that one of yours in this period, okay? So Aaron showed me this video. It's an awesome math video, by the way. That shows why you can't divide by 0. I need to wait to show you though, because we haven't learned some of those skills yet. Once you learn those skills with quadratic factoring and whatnot, you will understand why you can't divide by 0. And it's a really, really nice, clever video, okay? Here we go. From here, though, you would write this. X is less than 0, and x is the flip negative version. You can't have negative 0. So this is the same. And again, go to the graph. X's that are less will look like this. X's that are greater than will look like this. So right now, you tell me, does it look like a conjunction or a disjunction right now? It looks like a disjunction right now. What's the word that goes with this? Or. Because we're saying x is greater than 0 or x is less than 0. We're not finished yet. Because again, algebraically, it sometimes will give you an answer, but when you plug it in, it doesn't work. Right now, we're saying our answers exist in those shaded regions. Let's practice. Let's test one of these answers. Let's plug in 1. If I plug in 1, what's the absolute value of 1? 1 times 3 plus 2 is 5 less than 2. It's not. So my shaded region didn't work. And they're not extraneous solutions. They didn't work. The graph, this is why we learned the graph too. If I graph the left, don't shift, don't change anything, just graph what you see. This would be, first of all, you tell me, where's the vertex of what I just boxed? 0, 2. What's the slope? 3. So up 3 over 1, up 3 to the left 1. Now over here, if I graph 2, Nathan asked a really good question while you guys were doing the drill. This one right here says less than. There's no equal to. So when you go to the graphing calculator and you're used to seeing this equal to, it's a little bit different, right? So here's the thing that I ask. Is the red below or less than, right? Same word. Is it below the blue graph ever? No. So immediately, what's your answer? No solutions. Graphically, you can see this a lot easier than if you go here with all the algebra. So I'm telling you, from today, you're learning that, and I'll tell you right now, even going to calculus, a lot of times the algebraic way might be more work, but it proves it more definitively. But the graph can get you to the answer like this because you can see it if you know what you're graphing. Now look, Cole did this. In the back, let me show you what he did. I grabbed his calculator. So he used something that we learned back earlier on this year of not a function, he used a relation. Okay? So look at his graph. So if I come up here, this is his graph. He came over here, and on the let me press tab. On the relation, he put these as relations, not functions. Okay, and I'll show you how to do that real quick. If I had another calculator graphing page, and I do menu entry, number 3, it's not a function. He chose a relation, and it changed the input. So now he can put this in as an equation, which is what he did. And if you notice, with the first one, he put y is greater than all of this stuff. For the second one, he put y is less than 2. So it graphed above that line, and it graphed below the 2. No offense, but this is good practice. This is good to start because he's trying to put pieces together of what we've worked with. But this is not what inequalities are talking about with this. It's okay. This is not. All this is asking is, when is the red graph, when is the red graph below the other one? That's all it's asking. But that's still a good mistake. And I'm going to give his team. Did anyone else do this? If you did this, give yourself the team, give the team 30 points, okay, if you did that. But we're going to go through, can you get that back real quick? Here we go. Now let's circle our points. Here we go. Shh. If you found x by itself like this, give yourself 10 points. If you broke this up, give yourself 10 points. I still wanted you to look at it and still go with the algebra. 10 each. If you still showed this disjunction, give yourself 10 points. If you got OR, give yourself 10 points. Disjunction, give yourself 10 points. This graph is 10. This graph is 10. And the last one, the most important one, even though you showed all this extra work, we learned why it was no solution. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No solutions. 40. All right. Okay, so you got the 30 because of the graph? All right.
I know, right?
All right.
Restart.
Okay.
Wait, no solution, 20 points?
Just 10. Okay, you ready? All right, here we go. Shh. All right, so what I want you to do is I want you, real quick, from our answers here, I want you with me, and I didn't realize that this is still recording, no worries. We'll name 3 x values that are solutions. There's none. There's none. There's no solutions that are solutions. If I ask you to name 3 x values that are not solutions, what could you say?
4, 2, 1.
You could 4, 2, 1, 1, 3, 5, whatever. Just name x equals 3 different ones. No. Don't say infinity. Now, this is your last one before we go to the very, very last part of today, which I think you guys are going to easily get, especially the way you're answering all of these questions. So the last example, actually, you know what? Y'all did that very well. I'm just going to go to the last examples now. All right, so the last part of the 3rd video. The end of today, the very, very last part of today includes looking at graphing what you see. And this is very close to the quiz that you guys took last time. The only difference are the things that we learned today, okay? So looking at this, first of all, you tell me, which one which one of all of these am I going to use for what you see right? Just say it out loud.
It's the middle one. The middle one. It's the middle one.
It's that one right there. Listen. It's not this one because it's not a solid line. It's not these because it's not a solid line. So the only two it could be is y is less than or y is greater than. Because of the fact that we are shading, whoops, this goes back to inequalities with like systems of equations. We're shading all the y values that are above this graph. Okay? So because there's no equals, says that this will be a dashed graph. Go with me? Okay. Ryan, what's the equation of that?
I got negative absolute value of x plus 2 and then plus 1.
That's a nice speed too.
Good job, dude.
So this, heck yeah. So this is a reflection across the x-axis. It was shifted 2 to the left, and it was shifted up 1. And because of the fact it didn't have this, it's not going to be a solid, my answer would be y is greater than this stuff. And that was actually the fastest so far out of all the classes. Are there any questions from what we've graphed so far? Or what we talked about with this? Any questions at all? Let me ask you this. What's the slope?
1.
1. Once the slope is 1, right? Alright. What's the vertex? Negative 2, 1. Nice. What's the range?
You're
Like
funny.
one.
One.
Like, okay, y is
Oh,
less than
did you hear
x.
this? Did you hear this? This was, he knows where I'm going with that. Because this is not an equals to anymore. You with me? You're not analyzing just the function. It's not just a range. This is really looking at a shaded region. Okay, so you don't have a range answer with this. Are we good? Alright.
What it is technically we always remember saying at one point it's going to be shaded.
It's a different concept. Okay, ready? Here we go.
Sweet, Mr. Gomez.
Yes.
So what would the answer be?
I wouldn't ask you for a range on that. Okay, here we go. So these are all the steps to do what Ryan did seriously in about 3 seconds. Okay, so nicely done. All right, so now raise your hand if you want to tell me what the answer to this one is. Go for it, Aaron.
Immediately understands.
Y is
Greater than
greater than
the absolute value
the absolute value.
of x minus 3 minus 3.
Guys, you guys are killing it. And I knew that you were going to learn this fast because your transformations are strong. Okay?
Oh yeah.
So this is going to be y's that are shaded that are above that graph. Sophia, why is it dashed?
It's because there's no equal.
There's no equals. Perfect. Grant, what's the slope? 1. Well, why did we shade above? What about it? It says greater than, so we shade above. Are we good? Okay, one more and we will call it a day. Here we go. See all these steps just to do what you guys already know how to do. Oh, the last part is this. So if you're given the inequality and asked to make a graph, okay, I give you the inequality and I tell you to make the graph. Solve for y just like you would normally do. And you could get it on the left side. Okay? I don't think you have to get it on the left side. I want you to know both so that you know how to rewrite it. In other words, if I had something that was written like this, and I wanted you to put the y on the left side, Pranaz, how would you write that with the y on the left side? Perfect. Yeah, you read it right to left. Right? Okay. Draw the function based off the transformations that you see over here, just like you have as far as the class periods that we've done. If there is no equal sign, then we know it's going to be dashed. If there is an equal sign, we know it's going to be a solid line. And the last but not least, Grayson, if the sign is greater than, why do we shade above?
Because it's value 6.
Cause it's bigger, right? It's above. Nice. And if it's less than, it's just gonna be shaded below because it's obviously less than that line. What is that? Any questions? Nice job, Jay. Nice job. Alright, let me assign homework and work on homework for the rest of the period.